Okay, doke, so we're going to look at the mass of nuclei. Nuclei are very small, so are their masses. We're going to look at the individual masses of the nucleons. The mass of the proton. I'm going to use a different marker. This one is decidedly fading. Mass of the proton. 1. You don't need to memorize these. I'm putting up here so you can look at them and see how they compare to each other. 1.6726 times 10 to the negative 27 kilograms. 1.6726 times 10 to the negative 27. So that's a small number, right? The mass of the neutron is close, but not quite the same. Mass of the neutron, 1.67 so far, the same, but now 50 times 10 to the negative 27 kilograms. So they're both small, but the neutron is just a little bit heavier by maybe, looks like a fraction of a percent. Okay, but it's there and it's important, as we'll see. For comparison, let's look at the mass of the electron. 9.109 times 10 to the negative 31 kilogram. Also very small. See the exponents there. That's where the difference is. Negative 27, negative 27, negative 31. That's a big difference. Proton and neutron have about 1,830 times more mass than the electron. So the nucleus is very small compared to the atom. Remember the picture I gave you of downtown Decatur being an atom and the nucleus being a golf ball right in front of the old courthouse. So the nucleus is very small compared to the atom, but it contains virtually all of its mass. Okay? It contains virtually all of its mass because electrons are super lightweights. It's like comparing my mass to the mass of the pen. I pick up the pen, my overall weight doesn't change very much, right? It's negligible for most purposes. Okay, so almost basically the entire weight of an atom, and therefore of a molecule, and therefore of you and me, is all of our mass is found in our nuclei, not in our electrons. Okay, not in our electrons. Okay, now there's something called an atomic mass unit. The book calls it, I can't remember what the book calls it, something slightly different than that. But basically an atomic mass unit, okay? Atomic mass unit, AMU, which is, we're going to symbolize just little u. Okay? And the atomic mass unit U is defined such that the weight of a single carbon-12 nucleus, the mass of carbon-12 is exactly 12, actually I have to say 12U. Okay, so that means that a single U, an atomic mass unit, is 1.6605559 times 10 to the negative 27th kilograms. Okay, so this is a unit of mass. U, the atomic mass unit, is a unit of mass, okay, which is appropriate when talking about nuclei. we can see if we use this definition here, where my paper go, there it is, that the mass of a proton is, let's see, 1.007276 atomic mass units, U. And the neutron is 1.008665 U. And I'm not going to write it up there for the electron. I just put the electron up there so you could compare it here to the masses of the proton and neutron. So every nucleon has approximately one atomic mass unit, one U. So uranium-238 is approximately 238 U. It's not, it's going to be less than that. Turns out, we'll see why later on. It's going to be less than that, but that's a ballpark. Gives you an idea. Okay, now I want to say one more thing about mass. So this is sort of the unit we use, is the atomic mass unit. But there's another way of expressing mass that is very common in nuclear physics. Okay, and that is to relate it to energy. And energy is what comes up next, I believe. Yes. And I'll start a new video here in a moment, but I want to show you the connection between mass and our next property, right? We're on properties of nuclei. The third property is going to be energy. What I want to show you now is how these two things, mass and energy, are related to each other. They're related through a very famous equation. So what's going to happen now, I'm going to say a little bit about how they're related, and then the next lecture is going to be all about energy. But here's how they're related. You have seen somewhere in your life this most famous of equations, even more famous than F equals ma. What's the most famous equation in all of physics that you've heard of at some point in your life? Right. It's E equals mc squared. Now what kind of E is this? What is it? That's energy. It's a certain kind of energy. We're going to call it E sub r, as our textbook does. Not all books do that, but we're going to call it E sub r. That is rest energy. Okay. All objects, whether it's an electron or whether it's a galaxy, or whether it's your pet dog, whatever, all objects have energy by virtue of the fact that they are objects. This pen has energy, not kinetic energy, energy due to motion, not potential energy, energy due to position in a gravitational field, but rest energy. This is a 20th century idea. Okay? This is Einstein's understanding about mass and energy. This pen has a lot of energy to it. And you find the amount of energy by taking the value of its mass, plugging it in here, multiplying by the speed of light squared, and getting your answer out in joules. This is known as rest energy. All objects have rest energy. And that's a lot of energy. A lot. Okay? The energy in 4 cups of water, you know, could light Atlanta for a year. That rest energy. Okay? Seriously. It could light Atlanta for a year. I have to do the exact math. But rest energy is a lot of energy. So, there's a connection between mass and energy. You give me mass, I can give you energy. You give me energy, I can give you mass. They are equivalent to each other. That is really the point of E equals mc squared. Mass is just a very concentrated form of energy. That's it. Mass is a very concentrated form of energy. They are interchangeable. You can produce mass out of pure energy. You can produce energy out of mass. they can be transformed into each other. Some amount of energy is equivalent to some amount of mass, and some amount of mass is equivalent to some amount of energy. Okay? And so oftentimes we measure masses using energy, because you can flip right between them using c squared as the conversion factor. We'll see how that works next. So the next topic is energy and how it relates to mass, sort of these two put together. Okay?